Right. I emphasize 2 points in the context of futures hedging. Number one, the life of the futures contract need not coincide with the hedge period. In other words, the hedge can be the futures position can be liquidated at the end of the hedge period, which may be earlier than the maturity of the futures contract, as you can see in this timeline. The hedge is being lifted at capital T. However, the futures continue to be live up to N. You can lift the hedge, you can close the futures position by taking a counter position and thereby cancelling the original position. That was one thing. The second thing I emphasized was that you can close the futures position at any point you feel appropriate, but for the purposes of analysis, it is conventional that we close the futures position at the end of the hedge period. That makes it more that makes it more uniform, that makes it more compatible with reality. Although if you feel that at any point you feel you are getting a good price in the futures market, you can obviously liquidate the position. And in any case, you can the profits that you realize could be invested for the rest of the hedge period, if you like. So, that is not a major issue, but maybe people would classify that as speculation, and therefore, we do not consider that aspect when we analyze a hedging situation. Hedging situation, we say that the hedge period will coincide with the liquidating of the futures position. Now, one more point, you see, these are intricate issues, nuances, better versus certain outcome. It is sometimes perceived that hedging gives rise to a better outcome in the sense that it improves the profits of the enterprise, of the entity undertaking hedging. It is actually not so. By the process of hedging, what we are ensuring is that the future cash flows would be more certain. We are not ensuring that the future cash flows would be better, would be more towards inclined or more aligned towards our profitability. That is not the case. When we do a hedging, when we hedge an exposure, what we want to do is that the future value of that exposure does not get influenced by the risk factor, whatever that risk factor is. So, what we are trying to ensure is that that particular account, that particular asset, liability, or whatever it is, becomes more certain as far as our future commitments to that asset, liability is concerned. But that does not of itself imply that that outcome is going to be better. In fact, there may be a situation where at the lifting of the hedge, you may realize that the prices have moved in a direction in such a way that had you not hedged the exposure, you would have made a higher profit. For example, if you have an asset A and you hedge against a fall in prices, right? You are hedging against a fall in prices of this asset at a future date. Now, that means what? That means if there is a fall in prices, the futures position that you take will result in a rise in prices, and therefore, your loss on the fall of prices would be counterbalanced. However, the converse will also happen because the payoff profile of the futures is linear. Therefore, if there is a rise in price, then there would be a fall in your position of the futures, and that fall in price will eat into the profit that you would make on the rise in price, as a result of which your net profit on the hedged position would be less than the price that you would have received had you not hedged the exposure. But then in that situation, what would have happened? You would have been exposed to the uncertainty of the price going up or the price going down. But by taking a futures position in a direction contrary to the direction of flow of the spot prices, for example, if you are long in the asset, you take a short futures position and vice versa, you ensure that the changes in prices either upward or downward are annulled by the reverse change in prices in the futures market. So, you get a more certain outcome, the deviations are reduced, but you may end up being on the wrong side of the price flow, and thereby not making a profit that you perceive that you could have made if you had not hedged the exposure. Perfect and imperfect hedging. A hedge is said to be perfect. A hedge is said to be perfect if the price, the cash outflow on the maturity of the hedge is certain, is absolutely certain. By virtue of hedging, you are ensuring absolute certainty of the price that you pay on hedging. For example, a forward contract is a perfect hedge. You decide to buy US dollars 3 months into the future at a certain forward price, let us say rupees 75 per dollar. That means, as of now you have crystallized the price at which you are going to get dollars at the end of 3 months. You have to pay 75 rupees, you will get $1, that cash flows are crystallized. That is a perfect hedge. However, for reasons that will come you will come to know later, very soon in fact, hedging by futures does not constitute a perfect hedge. There are many reasons for this, we will come to it, but for the moment hedging by futures is not a perfect hedge. Hedging by forward contract is a perfect hedge, because your cash flows under the forward contract are crystallized at T equal to 0 and will not change. We have two different types of hedging situations, as is probably anticipated, a short hedge and a long hedge. A short hedge entails creation of a hedge by taking a short position in the futures market. A long hedge entails taking a long position in the futures market to create the hedge. When would you create a short hedge? When you feel that by creating a short hedge you are able to make profits that would compensate you for the losses that you may make on your exposure. And when will you make profits on a short futures position? When the price of the futures falls. Now, as we know, in general, price in the futures market and price in the spot markets move in tandem. Therefore, you would like to make a short hedge, you like to take a short hedge when you are adversely affected by a fall in prices in the spot market. In other words, you either own the asset, you are long in the asset, or you are likely to own the asset. You are likely to own the asset, you own the asset, you want to protect yourself against a price decline in the spot market, decline in the value of a portfolio of securities, for example, that you hold consisting of long position in securities, and you want to protect yourself against a fall in the price of those securities, you take a short position in some futures contracts, so that if there is a fall in the price of those securities and your value of your portfolio declines, and the futures market mirror the price pattern of the spot market to some extent, then the futures market should also show a price decline, and because you are having a short position in that futures market, therefore you will make a profit in the futures market. The converse holds for a long hedge. Let us look at the actual price that you receive when you are doing short hedging. You are holding an asset, you want to sell that asset, and you are worried about a price decline in the asset, so you take a short hedge. Now, the price that you will receive when you lift the hedge and sell the asset in the spot market is given by this. This is the price that you will receive when you sell the asset in the spot market at the point you lift the hedge. Now, because you have taken a short position in the hedge, your profit on the short position in the futures market will be F naught minus F t. Remember, it is normally F t minus F naught for a long position and a short position is taken as the negative of a long position, there are mirror images of each other about the x axis. Therefore, that being the case, the profit on a short position becomes f naught minus f t, not f t minus f naught. Therefore, the net price that you pay that you receive is S t plus the profit on the futures, that is S t plus f naught minus f t. S t is what you actually receive in the spot market, and this amount in the bracket is what you receive because of your short futures position. You can write this as f naught plus S t minus f t, which is nothing but f naught plus b t. Now, the important thing here is f naught is known at t equal to 0. What is f naught? F naught is the futures price at which you have taken the futures position. You have taken a short position at t equal to 0. So, that price is known to you. So, the only variant is b t, and remember b t, as we have discussed, is a stochastic variable. It depends on the spot price and futures price at the point that you lift the hedge. Therefore, contrast it with the forward price. In the case of a forward, what happens? Your price would have been only f naught, the fixed value f naught. However, in the case of futures, it contains a unpredictable term b t. Of course, you will argue that at convergence, that is at maturity of the futures contract, b t will be 0, agreed. But that is a special case when you are holding your hedge period coincides with the maturity of the futures contract, which need not necessarily be true. In general, it is not true. Therefore, b t may not take a 0 value. It can take a 0 value only when t converges with the maturity of the futures contract, which I reiterate need not necessarily be true. Similarly, in the case of a long hedge, using the same steps, the price that you receive is minus of f naught plus b t. F naught again is known to you, b t captures the random element. I mentioned a couple of slides back that forwards gives you a perfect hedge, futures does not give you a perfect hedge. I also pointed out just now that one of the reasons is that b t is present in the case of a short hedge as well in the case of a long hedge, but b t is present in the price that you pay or you receive under the futures hedge, and b t is stochastic. That being the case, b t's value is not perfectly predictable, and therefore, we do not know the precise cash flow that is going to occur at the point that we lift the hedge, and therefore, it is not a perfect hedge. This is called basis risk. What I have alluded to just now is called basis risk. In addition, of course, futures contracts are subject to marking to market. In other words, they are marked to market on a daily basis, and in case there is a change in the underlying interest rate at which margin accounts are being maintained, obviously that arbitrage that we talked about would be disturbed. So, that is another reason which could cause imperfection in futures hedging. Basis risk can have different contributory factors. The underlying asset may not be the same, we have not discussed that yet. So far what we have been talking about is on the premise that the underlying asset is the same as the asset being hedged. We have not discussed the situation when they are not the same. Non-identical maturity we talked about just now, when the maturity of the futures contract does not coincide with the maturity of the hedge period. And then there is the issue of integral lot size. You cannot have futures contracts in any lot size that you want. For example, you cannot have $230.82 futures contracts. You have to have standardized futures contracts. So, that lot size issue also creates imperfections in hedging. So, these are some of the reasons as a result of which futures hedging is imperfect, but it has certain discrete and definite advantages. The advantages emanate from the tradability of the futures. You can lift the hedge anytime you feel appropriate. In the case of forward hedging, you are bound by the contract between the two parties. So, this tradability, the liquidity and the flexibility that is allowed by virtue of the tradability of these futures contracts is a very significant contributor to their popularity as a hedging instrument. We will now take these issues one by one. Now, obviously, if futures are if you want to hedge against a price rise in US dollars, for example, let us say you've got admission in a US university and you have to pay fee in US dollars at the end of 3 months from now, and you want to hedge yourself against a rise in the price of US dollars, because at the end of 3 months from now what you are going to do is you are going to buy dollars from the market and remit them to the US university. Now, how will you do it? You will take a position in the US dollar futures contract, which would be trading on Indian exchanges. Now, if US dollar futures are trading, then there is no problem. If the exposed asset and the underlying asset of the futures contracts are the same, we do not have any problem regarding this particular aspect. They should be the same. US dollars, the exposure have underlying as the US dollars in the futures market. But what happens if the future, you see, futures are not traded on each and every asset. What happens if your exposure is in Mexican pesos and your pesos futures are not traded in India? Then you have a problem. Or your exposure is in say Bangladeshi taka, and taka futures are not traded in India, or some such situation where your exposed asset is different and the underlying asset futures on that underlying asset are not traded on Indian markets. You cannot have access to, you do not have access to such futures. Then what to do? Then obviously the right thing to do is to look for an asset that has the closest correlation with the asset that you want to hedge. The exposure that you want to hedge, look for the asset that has a closest correlation with that. For example, if Mexican pesos prices are very closely correlated to US dollars, you take a future in US dollars. If Mexican pesos are aligned with Great Britain pounds or euros, you take positions in euro futures or Great Britain pound future. So, you have to look for an asset, underlying asset, which is closely aligned, whose price process is closely aligned to the price process in which you are, of the asset in which you are exposed. That is the choice of the underlying asset. Now, there can be situations, at least hypothetical situations, where the asset is negatively correlated. If the asset is negatively correlated, you see, so far what I have been discussing is that the price in the futures market is positively correlated with the price in the spot markets, which is usually the case. For academic interest, if the price in the futures market is negatively correlated with price in the spot market, so you have a different underlying asset and you find that this asset is really strongly correlated with your exposure, but with a negative correlation close to -1. You can still build a hedge with this. The only thing is, in such a situation, instead of taking an opposite position, for example, protecting your long position in the underlying asset with a short futures hedge, you would rather protect your long position under in the exposed asset with a long position in this kind of futures. But this is more of academic interest than anything else. Normally, the correlation between futures prices and spot prices is positive. Now, we come to the choice of maturity month. The immediate reaction should be, or would be, is that we should choose the month which is closest to the maturity of the hedge. Suppose we want to hedge for 3 months, then we look for a contract. For example, let us take this particular set of data. You have a payable as of today is February 20th, for example, let us say, and you have a payable that is going to mature on June 1, that is a US dollar payable. You are an Indian firm, today is February 28, you are an Indian firm, you have a 3-month US dollar payable that is going to mature for payment on June 1. So, the immediate reaction is select the future that is closest in maturity to June 1. Let us analyze this a little bit more closely. First thing that we see is that futures contract, there are no futures contracts that mature on June 1. Futures contracts mature on the 3rd Wednesday of June, September, December and March. So, either you take a position in 3rd Wednesday June futures or September, December or March, the 3rd Wednesday futures. Then you look at the data. Of course, because you have to pay US dollars against a payable, you will take a long position in US dollar futures. So, that if there is a price rise, you incur a loss due to purchasing the dollars in the spot market, you compensate it by a price rise in the futures market, which will give you a profit because you are holding a long position in US dollars. Let us say your data as of t equal to 0, that is as of February 28th, the day you decide to hedge is this. The spot rate is ₹70 per US dollars and the futures rates are for June futures 70.25, September futures 70.75, December futures 72. The basis of these 3 contracts at t equal to 0 is obviously 70 minus 70.25, that is minus 0.25, 70 minus 70.75, that is minus 0.75, 70 minus 72, that is minus 2. So, this is the data that is available to you at t equal to 0. You have to select which of these contracts that you have to select, which is appropriate for your hedging strategy. How will the hedge operate? Well, as on 1st June, what you will do? You will go to the market and you will buy the requisite number of dollars from the spot market, because we are assuming that this futures are cash settled. So, you will go to the market and you buy the US dollars at the spot rate that is prevailing at that point in time. At the same time, you will liquidate the long position in the futures that you took at February 28. You will now liquidate these futures as on June 1. The difference in price you will get, and you will, in case the price rises in the spot market compared to what it is on February 28, you make a loss, and that loss is compensated by the price increase in the futures, because futures prices are likely to increase with the increase in spot prices. Therefore, you are likely to make a profit on your long position, which will compensate you for the loss that you make on the purchase of your US dollars, your short position in US dollars. Right. So, the price change in the spot position is ST minus H0, the price change in the futures position is FT minus F0. Now, therefore, in order that the hedge be effective, you want that delta S should be greater, delta F should be greater than delta S. The price change in the futures position should offset the price change in the spot position, the exposure, the US dollars. Simplifying this, we get Ft minus F0 is greater than St minus H0, or S0 minus St is greater than St minus Ft, or basis at, this is the basis at t equal to 0, this is B0, and this is the basis at t equal to capital T. You want, in order that the hedge should be successful or hedge be optimal, you want that B0 should be greater than Bt. Now, let us return back to the data. You see that all the bases are negative, all the bases are negative at February 28. It is very logical to assume that when you work out the basis on June 1, you again find the basis to be negative, unless some extraordinary event happens. at least at the stage of planning on February 28, you would feel that this negativity of the basis would likely continue into the future. Okay. So, if that is so, if the bases as on June 1 are also likely to be negative and you want B0, you want that B0 is greater than Bt, this implies, and both are negative, then you want in effect mode of B0 is less than mode of Bt, because they are negative. So, you want that the magnitude of the bases at B0 should be the magnitude of bases at Bt. In other words, you want the basis to widen. The more the basis widens, noting that it is negative, the more the basis widens, the better would be the performance of the H. Now, this is a June contract. This would mature on 15th of June. This is 15th June. Let us say roughly 15th June. This would mature on 15th September and so on. 15th September, 15th December. Now, because this June contract is likely to mature around 15th of June. Today is 1st of June now. It is very likely, and we know that on 15th of June, because this contract is maturing, the basis has to tend to 0. In other words, the spot and futures price as on 15th of June of this contract will be the same. So, basis would be 0. So, working backwards and assuming that there is no discontinuous jump, which is a logical assumption, assuming that there is no discontinuous jump and that basis is converging to 0 at a uniform rate or more or less uniform rate, we infer that the basis in the case of this contract is going to be very small. The magnitude of the basis in the case of this contract Bt is going to be close to 0. Why? Because it is going to be 0 at 15th of June. We are at 1st of June. We are very close to the maturity of the contract. Therefore, logic says that if the basis is going to converge at a uniform rate or approximately a uniform rate, then the basis would be close to 0. What do we want? We want that the basis should widen, and here we are seeing that if you choose a June contract, the basis is narrowing. Therefore, with this logic built in, we do infer that if this was the only criterion on which the hedge is to be determined, we would not choose a June contract. We would rather go for a September or a December contract. In other words, what I am simply trying to say is that there can be situations where the immediate closest contract, maturity contract, immediately closest maturity contract to the hedge maturity time, hedge maturity period may not be the optimal contract. However, there is a catch. The catch is that as far as this analysis is concerned, this is perfectly correct, there is no dispute on this. But the catch is that as you move into the future, for example, as you move into June, December, March and so on, number one, the liquidity of the contract decreases, the tradability decreases, and number two, the basis risk also increases. In other words, the chances of the basis fluctuation also increases. So, these are two factors which are going to be counterproductive if you are going to choose a distant contract. In other words, as is usual in life, there are two opposing forces. Number one is this analysis which says that you pick up a distant contract. The other, that if you choose a distant contract, then the liquidity issue comes into play, and the basis risk also comes into play, which mitigates the benefits of hedging ab initio. Now, this is a diagram which depicts what I have explained so far. We had a long hedge here we had a long hedge, we had a negative basis. So, the optimal choice is a distant contract. And if you have a short hedge and you have a negative basis, you have a near contract. For example, in this case the June contract would have been more desirable, and similarly is the converse is the case when you have a positive basis. As an exercise, some of the viewers may like to work it out. Now, we come to the issue of number of contracts. Before talking about number of contracts, let us try to understand what we are trying to do. We have made the assumption that I mentioned last time that standard deviation is the most popular approach to the measurement of risk. Standard deviation continues to be the most, at least for most practical purposes, the measure of risk, although there are improvements, there are improvisations as well, but for purpose of analysis at our level, standard deviation continues to dominate. We will talk about it in the next class. Thank you.